So this will give you 1 over 1,296. Okay, cards without replacement. What's the probability of getting an ace, and then a king, and then a queen, then a 5, and then a 10 in that order? So you have 4 aces out of 52. You take that card out and you throw it across the room. 4 kings out of 51 cards. Take that card, throw it out. 4 queens out of 50. 4 fives out of 49. 4 tens out of 48. The probability of that happening is 1,024 over this huge number. 311, comma, 875, comma, 200. Or it's point a lot of zeros. Okay, the probability of this happening is very, very slim. Okay, tying these two together, the and probability and the or probability, given this information right here, the and probability is multiplication. So this would be equal to the probability of B times probability of D given B. Now the reason why we know that this is dependent is because the probability of D given B, which is 0.5, says right here, does not equal the probability of D, which is 0.3. So by definition, we know that these two things are dependent. So this is going to be 0.4 times 0.5, or same thing as 0.20. Now, because the probability of B and D is not equal to 0, then we say that it is mutually exclusive. So because the probability of B and D is not equal to 0, it is not mutually exclusive. So we need the probability of B plus the probability of D minus the probability of B and D. So that's going to be 0.40 plus 0.30 minus what we just found, 0.20, same thing as 0.50. The last item here is just recapping everything I said into one nice, neat little table.